Okay, problem number 3. A lot going on in this problem. Not the easiest series problem for sure. So they told us that f of x is the natural log of 1 plus x cubed. And they gave us the series for natural log of 1 plus x. So one of these pre-existing series could make it a lot easier to write our series. So they want us to write the first 4 terms of this series. So all I got to do, natural log of 1 plus x cubed, is take that x cubed and plug that x cubed in for x in that one. So that's what you see me doing here. That becomes x cubed squared, x to the 6, and then over here, x cubed to the n, x to the 3n, general term. Next part of the question says, the radius of convergence is 1, determine the interval of convergence. So remember, if they just asked to find the interval of convergence, you would do a ratio test and find the limit and go from there. So they've already done that work for you. They told you the radius of convergence is 1, so we know it's between -1 and 1. So now we just have to check the endpoints. I'll start with the easier one first. Check 1 first. Put 1 in for this. And you just get -1 to the n plus 1 over n, which is an alternating series. The limit as n approaches infinity is 0, therefore it converges by the alternating series test. The other one, however, you plug in the -1, you get -1 to the n plus 1, and then you get a -1 to the 3n over n. This becomes -1 to the 4n plus 1, and 4n plus 1 is always odd. Multiply by 4 is an even, add 1, it's always odd, so it's not an alternating series. It looks like it's this one, but it's not an alternating series. It's just actually -1 over n, which is a divergent harmonic. So it's open on -1 and closed on 1. Part C says, write the first 4 non-zero terms of f prime of t squared. So the first thing I had to do is find just f prime of x, and then I'm going to plug in the t squared. F of x was just on the back, so all I did was took the derivatives of all those terms, and this is what I wound up with. And then I plugged in t squared, so I went up with 3t to the 4th minus 3t squared, plus 3t to the 16th minus 3t to the 22nd. Then it says, if g of x is the integral from 0 to x of f prime of t squared, use the first 2 non-zero terms to approximate g of 1. So that just means I want to integrate it, right? So I'm going to go from 0 to 1. These first 2 terms, so I went up with this, 3t to the 5th over 5 minus 3t to the 11th over 11th, from 0 to 1. Just get 3/5 minus 3/11, which is 18/55. And then it says, show that that approximation must differ by less than 1/5. That's just the next term, right? Whenever they ask for an approximation differing in series, it's the next term. So the next term is going to be a 3t to the 17th over 17. You just follow the pattern or integrate one more term, 3t to the 17th over 17. Plug in the 1, you get 3/17, which is less than 1/5. That's it for that problem.